Today we are going to study something called the normal line, and we're going to be able to write an equation of a normal and a tangent at any point of the basic functions that we have been able to find derivatives so far. So normal and tangents. A normal to a curve is a line that is perpendicular to the tangent at the point of contact. Okay, so what we mean by that is, if I've got a graph with a parabola, and then I've got a specific point, and I draw the tangent line to that point, shown there in the green. The normal also goes through that point, and it's just perpendicular to the tangent. So basically you kind of have to know the tangent in order to get the normal. How do we know the tangent? Well, it's got the same slope as the derivative at that point. How do we do perpendicular once we know slope? Two words: opposite, reciprocal. So for example, if my slope was 2, the opposite reciprocal of that, or the slope of the normal to that line, would be negative 1/2. We do the opposite, it was positive, it became negative. We do the reciprocal, 2 over the implied 1 becomes the 1/2. So two words: opposite, reciprocal, that's your perpendicular. What do we need to find an equation of a line? Well, a slope's a good thing, and as I showed a couple classes back, I'm a big fan of point slope form, which is y minus y sub 1 equals slope times x minus x sub 1. If I know my slope from my derivative, and I have a point, then I can write an equation of a line using that formula. Alright, example 1. Find the slope of the tangent line and the normal line at the given point when f of x is as follows. So for number 1, f of x, or our function, is x to the 4th power, and we want to find the slope of the normal and tangent lines when x equals 3. For the second bullet point, our function is 2x squared plus x plus 2. We want to find the slope when x equals negative 1. And then our last equation, f of x equals 6 over x squared. We want to find the slope when x equals 2. Remember, slope is the same thing as derivative. We got to find our derivative and then use your x value to find out the slope at that specific spot. Once you have the slope of the tangent line, which is what you get from the derivative, you can then use that last slide to help you out with the normal. This shouldn't take long at all. The derivatives will take seconds. Plug in some values and then do their opposite reciprocals for the normals. So 5 minutes tops is all this should take. You can pause the video now. All right. So first and foremost, we need to know the derivative of x to the 4th, and that's going to be 4x to the 3rd. The slope when x equals 3 is going to be f prime of 3 equals 4 times 3 to the 3rd power. 3 to the 3rd power is 27. And 27 times 4, I believe, is 108. So we know that our slope when x is 3 is 108. We now want to know the slope of the normal line, and that's going to be the opposite reciprocal of that. So it's going to be 1 over 108. That would be the reciprocal, and then negative. So our perpendicular slope is negative 1 over 108. Extremely steep slope here, extremely gradual slope there. All right, moving on to the second bullet point. Start with our derivative. F prime of x is equal to 4x plus 1. F prime of negative 1, meaning the slope, meaning the slope when x is negative 1 is equal to 4 times negative 1 plus 1, also known as negative 4 plus 1, negative 3. So if our slope of the tangent is negative 3, then our normal is going to be 1/3. Last but not least, 6 over x squared when x equals 2. Let's rewrite this equation as 6x to the negative 2 power. And we'll do our derivative rule. So f prime of x is equal to negative 12 x to the negative 3rd power, also known as negative 12 over x to the 3rd power. If we want to know our slope when x equals 2, this would be the slope of the tangent line. We have negative 12 over 2 to the 3rd power, also known as negative 12 over 8, or would that be 3 halves? Oops, 3 halves. Okay, so negative 3 halves would be our slope of our tangent line, our normal, opposite, reciprocal, so 2/3 positive. Example 2. Write the equations of the lines that are tangent and normal to the equations y equals x squared plus 2x minus 1 when x equals 3. So I want you to actually write the equation of a line. I personally would use point-slope form. In order to do point-slope form, we need slope and we need a point. Well, at the moment we have neither of those. We have an equation of a line and an x value. Well, x value is half of a point. If I already know an x value, the question is how do I get a y value from a function? And we already know that if I want a slope, I need to do the derivative. And again, we have a specific x value there. Just take a few minutes, talk to your group to work this one through. Maybe about 5 or 6 minutes. You can pause the video now. All right, let's go over this one together. Again, to write the equation of a line, we need 2 things, a point and a slope. We can start with the point. I already know that x equals 3, I'm trying to find y. So y equals 3 squared plus 2 times 3 minus 1. So 3 squared is 9 plus 6 minus 1. So 15 minus 1, 14. So my final point is going to be 3, 14. I have a point, I just need a slope. To get slope, we do our derivative. Y prime is equal to 2x plus 2. That's our derivative. I want the slope when x equals 3, so my slope is going to be equal to 2 times 3 plus 2. 2 times 3 is 6, plus 2 more, it gives me 8. So I have a slope of 8. I have a slope, I have a point, let's use point-slope form. Y minus y sub 1 equals m times x minus x sub 1. My y value is 14, so y minus 14 equals my slope times x minus my x value of 3. We can distribute here. I have 8x minus 24 is equal to y minus 14. To get y alone, we add the 14 over to the other side, and we end up with y equals 8x minus 10. And that right there would be the equation of the tangent line. I just used the slope as it was. If I want to get the normal line, it's going to go through the exact same point. That's the point where I'm tangent, but I'll have a different slope. So I'm going to erase all of this. And I want, my slope is 8. For my normal, my perpendicular slope is going to be negative 1/8. We can repeat the same steps we just did before. Using point-slope form, we can do y minus y sub 1 equals m times x minus x sub 1. Our x and our y values are exactly the same, so I've got y minus 14 equals negative 1/8 times x minus 3. And really, technically, I have an equation already at this point. That's one of the reasons I like point slope form so much. But we can clean this up a little bit here. So we're going to distribute. We have negative 1/8 x. Distribute again. We've got positive 3/8 is equal to y minus 14. Once again, we'll add the 14 over to the other side. And for our normal, we will end up with y equals negative 1/8 x. And I'm going to reach for a calculator here. Obviously, it's going to be 13 and 5/8. No. 14, I'm just adding on. So 14 and 3/8, I guess, if you want to do a mixed number, but I'm not really a fan of that. So let's do 14 times 8, and add 3 more on. So I'm getting 115 over 8. 115 divided by 8 gives me 14.375. That's the one. So tangent, normal, equations. If you graph these, they should both intersect that one point. That point should be on this equation, and again, this should be your nice tangent, and this should go perpendicular to it through that same point. Something you can try out on your graphing calculators and take a look at it. All right, moving on to the next problem. So we're going to do the exact same thing here. We've got a bigger equation, and we've got another x value. Take about 5 or 6 minutes on this one. You can pause the video now. All right, let's take a look at this one. Again, we need a point and a slope. We have half a point, so to get the y value for our point, we plug it in. We've got y is equal to 2 cubed minus 2 times 2 squared plus 2 minus 1. 8 minus 8, if I'm not mistaken. 2 squared 4 times another 2 gives us 8 plus 2 minus 1. These cancel out, so I have 2 minus 1, also known as y equals 1. Love that. So my point is going to be 2 comma 1. Now let's do the derivative. So y prime is going to be equal to 3x squared minus 4x plus 1. I want to know the slope when x is 2. So we can say the slope is equal to 3 times 2 squared minus 4 times 2 plus 1. 2 squared is 4 times 3 gives us 12 minus 8 plus 1. And I believe we have a slope of 5 at that point. And we'll eventually need our perpendicular slope, which is negative 1/5. from this point you can use point-slope form just like we had done on the last problem and get our values that way. So, I was debating skipping it, but let's go ahead and do it anyway. We've got point-slope form, y minus y sub 1 equals m times x minus x sub 1. Our y value is 1, so we have y minus 1 equals our slope. This would be for our tangent. We have 5, x minus, 2. X value is 2. We can distribute. We'll get y minus 1 equals 5x minus 10. And then our final tangent equation is going to be y equals 5x minus 9 once we add the 1 over to the other side. For our normal, we're going to do the same thing. We can bring this straight over, except the 5 is going to become the negative 1/5. So we'll have y minus 1 equals negative 1/5 times x minus 2. And we'll have y minus 1 equals negative 1/5 x plus 2/5. Add the 1 over to the other side, we get y equals negative 1/5 x plus 7/5. Tangent and normal. Alright, our last problem here. Write the equation of the horizontal lines tangent to the equation y equals 5x squared minus 3x minus 1. Horizontal lines. Think about what a horizontal line is and what kind of slope it has. At the moment we don't have any points or anything like that. We need to get some. So take a few minutes, talk about this with your groups, maybe about 5 or 6 minutes. You can pause the video now. All right, let's take a look at this one. Horizontal lines. What kind of slope do horizontal lines have? Well, a horizontal line has no slope, 0. How do I find the slope of an equation? I do the derivative. The derivative of this one is going to be equal to 10x minus 3. And I want the derivative, or the slope, to be equal to 0. So I set it equal to 0. 10x minus 3. Bring the 3 over to the other side. I've got 3 equals 10x. And so x must equal 3/10. So I have an x value of 3/10 here. And that's where we have no slope. Problem says equations, but I think we're only going to have one specific spot, so we're writing one equation here. So we now have the x value just like we did on the other ones. We already know the slope is 0. We still need a y value, and so we're going to plug in our x into this equation. We've got y is equal to 5 times 3/10. I'm worried this is going to get ugly. Minus 3 times 3/10 minus 1. So 3/10 squared, we get 9 over 100. And then we'll have 9 over 10 minus 1. And some of you are hopefully reaching for your calculator, and maybe you'll beat me. Oh, 5 goes into both of these. Let's say 9 over 20 minus 18 over 20 minus 1. And so we have negative 9 over 20 minus 1. So what is that? Negative 29/20. So we have our x value, we have our y value, we know our slope is 0. Now think about the equation of a horizontal line. It always starts off y equals. Its slope is always 0, so the x value becomes kind of irrelevant. It's never going to actually cross through any x. So our final equation is just going to be y equals negative 29 over 20, unless my arithmetic here was bad, and you will have caught that and pointed out, and then it'll just be y equals that. Again, the horizontal line is always just y equals a constant, where the y value stays the same, and I believe that's the one we should be getting. For homework, we've got page 387, number 1, 2, 3A, 3C, and 3D. And then, of course, there's a worksheet to work on as well here in class.